Hello my people, I hope we're doing well. This is video 3 on the vocab. And we're just going to run through, and a lot of these you probably have an intuitive sense of what they mean. The vast majority of them you will. But I want to make sure that you really have your understanding nailed down, which is the whole purpose of going over all of this, right? Making sure we're kind of on the same page, that we're speaking the same language, and that these words mean something, mean the same thing to both of us, right? Let's go ahead and get started on the first one, absolute value. Now, absolute value is one of those things that a lot of math students just, they don't hate. It's just, it irks them a little bit because it doesn't come up often enough. It's a relatively easy principle and concept, but it doesn't come up often enough for students to be comfortable with using it, right? Their facility with employing it, dealing with it in the midst of an equation or a function or something like that. But the definition is really, really easy, okay? Now, when you're dealing with numbers, you need to remember that numbers, or it's good to think about numbers as having two aspects, like two different properties. One is its size, right? Its magnitude. And so if I say, you know, I have two brothers, Bob and Steve. Bob is financially responsible and has $5,000 in his bank account. Steve is a habitual gambler and owes the local bookie $100,000. Now, if you're talking about if you asked an accountant, right? Obviously, Bob is in the black. He's got positive $5,000. Steve is in the red. He's got negative $100,000. And so if you're dealing with like inequalities, obviously 5,000 is greater than negative 100,000. But if you're talking about just the sheer size of it, you know, Bob has $5,000. He is not as well off as Steve is in trouble. Like $100,000, whether it's positive or negative, is larger than 5,000 in a certain sense, right? So if you're talking about just sheer magnitude without regard to direction, like negative 100,000 is a large number, right? And absolute value, it tries to capture that, okay? Absolute value just is distance from 0. And that means like on the number line, okay? But basically, it is dealing with magnitude without regard to its sign, positive or negative. And so when we're dealing with absolute value, it's kind of like, Steve owes more than Steve owes more than Bob has, right? But who has more money? Bob has more money. So there's two different ways to think about greater than or less than. And it's really a matter of magnitude without regard. And that's why when you put the absolute value bars, you basically unnegativize the negatives. Prime numbers. Well, you ought to know prime numbers, right? They are ones that are divisible only by 1 and itself. So, 29. 29 is a prime number. Okay, 27 is not. 27 is, 3 cubed. 29 is. 31 is. 33, not. 35, not. Okay, and so you have to basically, and prime numbers, really, really easy. The one that I find students don't usually know is numbers that are relatively prime. And basically, if you're talking about numbers that are relatively prime, you're basically saying they have no shared factors besides 1. Okay, and that's sort of understood because all numbers share 1 as a factor. So, for example, 8 and 9. 8 and 9, neither of them are prime, but they are relatively prime because 8 and 9 share no factors, right? 8 is 2 times 2 times 2, and 9 is 3 times 3. They share no factors. And you run into this idea of relatively prime numbers, when you're dealing with finding the least common multiple, right? If you find the least common multiple, but they're relatively prime, the least common multiple is their product, right? So if I was trying to add 1/8 and 1/9, I would have to basically, because they don't share any factors, the least common multiple, and therefore the lowest common denominator, would be their product, would be 72. Now, factor, and we're getting into words that we use all the time here, right? Factor, term, like terms, variable, constant, monomial, poly. But basically factors, and I'm going to give you basically just, and this is not the official dictionary one, but factors are things multiplied. That's all they are. In its most basic sense, factors are simply things multiplied. Terms are things added. And of course, multiplied, that would include division, okay? And added, that would include subtraction. Since, you know, multiplication, division, same thing. Addition, subtraction, really secretly the same thing, right? And so basically factors are things multiplied. Terms, things added. Now, like terms, you know what they mean, but the way that I usually like to describe it is terms with identical variable configurations. And I almost got that in the box. Terms with identical variable configurations. So if you're, here, let me get a piece of paper. If you're dealing with like terms, and you have something like 3xy squared plus 5x squared y minus 1/2 xy plus 3/2 x squared y squared, all four terms have x and y. They have the same variables, but they don't have the same variables to the same powers at the same time, right? So basically there are no like terms here. But if I were to have something that looked similar, okay, there are like terms here, okay? X, y squared cannot be combined in terms of like terms with x squared y, okay? This is xyy, this is xxy. Those are not like terms. Their variable configurations are not identical. But these two are like terms, right? They have identical variable configurations. These two are as well. And therefore what I have is I'm going to have 5/2 xy plus 13/2 x squared y squared when I'm done, because there are two terms with xy variable configuration and two terms with x squared y squared variable configuration, which do then combine. Which of course all of this brings us to a very important question of what are variables? Well, variables basically they're basically expressions of value. So they're expressions where the value is either unknown or varies, right? And because it varies, that's why we call it variable, okay? So basically is an expression, and of course usually given by letters, whether they be Greek or the Latin alphabet or whatever, expression where the value is unknown or varies. Okay. Now, a constant is an expression that's constant. Man, it's almost like they name these things on purpose, right? An expression where the value doesn't change, where the value does not change, okay, and is known, okay. Now, monomial, that is an expression, okay, that is a single term expression. And of course, a polynomial is a multi-term expression. And of course, polynomials can be subdivided into, binomials and trinomials and all sorts of fun stuff like that. Okay, just wanted to, obviously these, like I said before, the vast majority of them you have an intuitive understanding, even if you don't have a way that you have explicitly defined them in the past. But I want to make sure that we all understand what's going on with these things, that we're all speaking the same language, hence why I'm going through the trouble of actually defining these terms and making sure that you know how I want you to understand them. We will continue this in the next video. If you have any questions, as always, shoot me an email. Bye.